Hi everyone, welcome back. Today we are going to see about the Zener Diode. So this is the symbol of Zener Diode. It has the two terminal, one is called anode, another one is called cathode, and it has the two layer, one is nothing but P type and another one is nothing but N type, which is similar to the ordinary PN diode. So then what is the difference between the ordinary PN diode and the Zener diode? So for the ordinary diode, it is exclusively operate only on the forward bias condition. Only on the forward bias, it does not conduct in the reverse bias region, reverse bias condition. But the Zener diode is specially made to operate in reverse bias conditions. Then what is the difference between these two? Here, the ordinary PN diode is lightly doped so that we require high voltage to break down the depletion layer. But in the Zener diode, it is specially designed with a highly doping property. So less than 6 voltage is sufficient to break down the depletion layer. And this is a forward bias. The forward bias which is similar to the ordinary PN diode. So here, while combining the P-type and N-type semiconductor, it forms a layer. That layer is called barrier potential, or it may be called as depletion region. So this is due to the diffusion process. The diffusion process is nothing but the Sargic area, it moves from high concentration area into low concentration area. That is nothing but the holes from P-type to N-type and the electrons from N-type to P-type. So, for this forward bias, the positive terminal of the battery is connected with the P-type semiconductor, and negative terminal of the battery is connected with N-type semiconductor. So, while increasing the voltage level, the positive terminal of the battery, it repels the holes in the P-type region, the P region, so the holes can move from P-type to N-type. Similarly, the N-type is the negative terminal of the battery is connected with the N-type semiconductor, so the electrons gets repelled. So the electron can move from N-type N region into P region. So during this process, the depletion layer is slowly decreases by increasing the supply voltage. So once the supply voltage it reaches the 0.3 for germanium, 0.7 for silicon, the full barrier potential can be eliminated, then the current will suddenly increases to the maximum value. So after that, if you are increasing the small voltage, there will be a huge change in current. Okay, so this is nothing but a forward bias. So this is nothing but threshold voltage, or it may be known as knee voltage, which is similar to the ordinary diode. But in the reverse bias condition, here the voltage is less than 6 voltage, which is enough to break down the depletion layer in the reverse bias conditions. So because of the heavily doped property. So in a ordinary diode, the reverse bias is in microamps because of due to the leakage current. The leakage current is nothing but across the layer there will be an recombination of holes and electrons. But here the depletion layer can be eliminated while supplying the reverse bias voltage less than 6 volt. So this the elimination of breakdown is nothing but and threshold voltage, or it may be knee voltage in the reverse bias, Zener knee voltage. Okay. So it is specially made to operate only in the reverse bias conditions. And this is the main application of the Zener diode. The Zener diode can be used as for clipper, which is used for the clipper. So to clip certain amount of waveforms, certain amount of output. And another one major application is voltage regulator. So the Zener diode, it acts as an voltage regulator. So in order to maintain the constant output voltage throughout the operations, just like stabilizer. So if it may be change in supply voltage or change in load resistance, or because of the losses, it may be anything, any cases. But we are the Zener diode, it regulates the voltage level in order to maintain the constant output throughout the operation which is connected with load. Okay, and this is an assessment. The Zener breakdown of PN junction is usually occurs in forward bias or reverse bias, neither forward bias nor reverse bias, or both. So put your answer in the comment section, and these are the few references for this topic. Thank you.